Hi, let's solve paper 2 variant 2 February March 2025 AS level physics. Question 1a. Explain what's meant by the accuracy of a measured value. Accuracy refers to the degree of agreement between a measured value and the true value of a quantity, or how close the measurement is to the true value of a quantity. So the closer the measurement is to the true value, the more accurate it is. And accuracy is affected by systematic error, and this is the error which arises from a faulty instrument or flaws in experimental methods. B. Two cubes A and B are measured to determine the density of their materials. Table 1.1 shows the measurements for cube A, and you're supposed to show that the calculated density of this material is as provided. So density is equal to the mass over volume. A cube is a three-dimensional figure which has 6 faces of square shape, and each of these faces has 4 sides that are all equal in length. Therefore, where volume is equal to cross-sectional area multiplied by the length. Cross-sectional area would be the base and height, so that's L times L, and then the length is also the same in a cube. So the volume of a cube is its length cubed. Therefore, the density would be mass over length cubed, where you need to have these in standard units. So 31.3 grams would be converted into kilograms, and the volume as well would be converted from centimeter to meter, and then you'd cube that to lead to your answer. Calculate the percentage uncertainty in the density of the material of cube A. The percentage uncertainty of density depends on the percentage uncertainty of mass and volume. Now these values are provided in the question. Although you're not provided directly with the percentage uncertainty of volume, you can find that using the percentage uncertainty of length. The way you do that is, whenever two variables are multiplied or divided like they are in this case to find the density, you would add up their percentage uncertainty to find the value of resulting percentage uncertainty. So let's look at how to find that value for the mass. It is equal to the value of uncertainty divided by measured value multiplied by 100. So that would be 0.5 over 31.3 times 100 for mass. And for volume, it would be, okay, so volume here is length cubed. That means you can find the percentage uncertainty of volume by finding the same value of length and multiply that by the power that the length is raised to. So you would simply multiply 3 times 0.01 over 1.53 times 100. And then you would sum these two values to get your final answer, which is 3.6%, correct to two significant figures. The density of the material of cube B is determined to be 9.2 times 10 raised to 3 kg per meter cube with 6% of uncertainty value. State and explain whether A and B could be made from the same material. To answer this question, you need to understand what the percentage uncertainty actually tells you about a measurement. So let's look at that value for box A. It has a density of 8.7 times 10 raised to 3 plus or minus 3.6%. Now I want to convert this into actual numbers. So you would find 3.6% of the value of density, which for A is equal to 301.3. Now to find the actual possible range of values that A could possibly be, you would add and subtract this value from the measurement. Because remember, measurements are not always accurate, therefore they have this margin of error. So when you do that, you would get to a range between around 8,400 to 9,000. This is the actual range of values between which the density of A could lie. Now let's do the same for B. B has 6% of a margin of error in its possible values of density. And so you would add and subtract from the measurement, which leads you to a range of 8600 to 9800 kg per meter cube. These are, once again, this is the range where the actual value of density of box B could lie. Let me put that on a scale to visualize this. Let's say this is 8000 kg per meter cube, and then you go 100 over with each unit. And so that would be 8.4, 5, 6, 7, 8, 9. That's 9000. 1, 2, 3, 4, 5, 6, 7, 8. That's 9800. Let's mark 8600 on the scale as well. There would be here. Okay, so the possible range of the density of A lies from 8400, that's this mark over here, up until 9000. And then the possible range of values for B lies from 8.6 up until 9.8. As you can see, this region over here is the overlap of possible values. Now, if A and B both were to have a value that falls in this region, that would imply both of them are made of the same material, because the same material would result in objects that have the same density. So that's why your answer would say that the range of possible values of densities of boxes A and B overlap, therefore they could be the same. Question 2, state the principle of moments. Well, that states for a system to be in equilibrium, the sum of clockwise moments about a point must be equal to the sum of anti-clockwise moments about the same point. Okay, now you have a solid plastic cylinder which floats in water, and it's used to support one end of a horizontal uniform beam AB as shown in figure 2.1. This beam has a length of 6 meters and it weighs 1700 newtons. The beam is attached to the solid ground with a hinge at A, and a cylinder is floating vertically in the water. The top of the cylinder is attached at its center to the beam at a horizontal distance of 5 meters from the end A. The cylinder applies a vertical force of 1300 newtons to the beam. The beam being uniform means that the weight of this beam acts from the center, from the exact center of the length. So that would be around 3 meters from either of these hinges. Let's say the center is somewhere around here and it weighs 1700 newtons. This is where the downward force acts. Next up, the cylinder exerts a force of 1300 newtons to the beam, so that's going to be upwards. And then lastly, you have the weight of the person standing on this beam who weighs 660 newtons. Now we are looking at a question that requires you to recall your knowledge of moments, and as it is written over here, the beam is in equilibrium, which means the sum of clockwise moments must be equal to the sum of anti-clockwise moments. You are supposed to take moments about A, determine the distance x from A to B. Okay, that means A over here will be your pivot, and you are supposed to find this distance over here. Let's divide these forces into those that cause clockwise moments and anti-clockwise moments. The weight of the person and the weight of the beam both act downwards. That means both of them will result in clockwise moments, and since the force from the cylinder on the beam acts upwards, it would cause anti-clockwise moments. Now we don't have any other forces acting on this system. That means the clockwise moment due to these two forces must be equal to the anti-clockwise moment due to force from the cylinder on the beam. Now let's put that into an equation where moment is equal to force multiplied by perpendicular distance from the pivot, and we also know that clockwise moment must be equal to anti-clockwise moment to attain equilibrium. Clockwise moment would be caused by weight of the beam, which acts from the center point, which is 3 meters away from end A, and then to that you would add the clockwise moment due to the weight of the person, but you don't know his distance from the hinge A, and that is equal to the anti-clockwise moment caused due to force from the cylinder on the beam, and that acts at a distance of 5 meters. So this distance x is equal to 2.1 meters, correct to two significant figures. The bottom of the cylinder is submerged in the water to depth y as shown in figure 2.2. The beam is still attached to the cylinder but not shown. So imagine the beam still being attached to the top of the cylinder. The cylinder has a mass 11 kilogram and diameter 0.78 meters. The beam exerts a vertical force of 1300 newtons on the cylinder. The cylinder is in equilibrium. The cylinder was exerting an upward force of 1300 newtons on the beam, and now we are informed that a force from the beam also acts on the cylinder. Other than that, we are informed about the mass of the cylinder. Show that the upthrust acting on the cylinder is 1400 newtons. Because this question is just for 1 mark, that means it should be pretty straightforward. So let's look at the system over here. They tell you, the keyword over here is to note that the cylinder is in equilibrium, and what that means is the sum of upward forces acting on this cylinder must be equal to the sum of downward forces acting on it. The only force acting upward on the beam would be the upthrust. The downward forces on it would be the force from the beam, so that's 1300 newtons, and then the weight of the cylinder, which is mass times the gravitational constant, so that's 11 times 9.81. So that's what so that's the relationship you'll use to find upthrust. The total forces acting upwards must be equal to the sum of the forces acting downwards, which is force from the beam as well as the weight of the cylinder, which is how it turns out to 1400 newtons. The water has density of 990 kilogram per meter cube. Calculate depth y. Now that we have both upthrust and density, this should make you recall the formula of upthrust, where this value is equal to the density of surrounding liquid multiplied by the gravitational constant multiplied by the volume of submerged object. So density of the surrounding liquid, which is water, is 990. You know the constant value as well. Volume is equal to the cross-sectional area multiplied by the length of a certain object. The cross-sectional area for this cylinder would be the area of a square, that's pi r squared, and then the length. Remember that this length is only the length or the portion of the cylinder that's submerged in the liquid. So this is y over here, which is why you would multiply this product with pi r squared times y. Now we were informed that the diameter is 0.78, therefore the radius would be half of that. Radius would be equal to 0.39 meters. And since we already know the value of upthrust, we'll equate it to that. So y would be equal to upthrust divided by density times gravitational constant times pi r squared. which is equal to 0.30 meters. Correct to two significant figures. The person can stand anywhere between A and B. Let me draw here again the scenario that we are working with. So you've got A at the hinge, B at the completely other end, and the cylinder being 5 meters away from hinge A. Sketch the variation of the depth of the bottom of the cylinder with distance of the person from A for distance between 0 and 6 meters. Numerical values are not required. Also, a certain portion of the cylinder submerged in water. Let's start with the origin. The x-axis is the independent variable. Here we'll increase that value, which is distance from A, from 0, and see how the depth of cylinder changes with it. When the person is at 0 meters from the hinge, or let's say the person is at A, his clockwise moment is 0 because there is no distance from the hinge. That means the total clockwise moment is reduced to the clockwise moment due to the weight of the beam alone. That means now the total value of clockwise moment is reduced. And for this beam to remain in equilibrium, the anti-clockwise moment must also drop to balance this, which results from the 1300 Newton force acting upwards from the cylinder onto the beam. What that means is, even when the person is at A, when his distance from A is 0, there is still some clockwise moment due to the weight of the beam. Therefore, there is still the need for anti-clockwise moment to maintain this beam in equilibrium, and that's why you will need some force from the bottom of the cylinder pushing it upwards to result in this anti-clockwise moment. And this force arises due to upthrust acting on the cylinder. That can only happen when at least some portion of the cylinder is submerged in water. Therefore, the depth must be a non-zero value. So let's mark that anywhere that's a non-zero value on the y-axis. Moving forward, when A moves further away from, when the person moves away from A and closer to B, let's say he's somewhere around here now. This will result in his weight causing clockwise moment. So now the sum of clockwise moment will have increased, and once again, to maintain the beam in equilibrium, the anti-clockwise moment must also increase, and that is equal to the force from the cylinder on the beam times the distance. Since we are not talking about distance of the beam from the pivot, we are only considering the force that results from the cylinder to the beam due to the depth of cylinder in the beam. We'll consider how this force must change. So anti-clockwise moment is increasing, therefore the force from the cylinder on the beam must increase. And remember that this force is proportional to the upthrust acting on the cylinder. When the upthrust increases, the upward force will increase. Therefore, upthrust, which was equal to the density of surrounding liquid, upthrust force, which is proportional to the depth. Remember, this was our formula. It is proportional to the depth of the submerged object in the fluid. If you want to increase the force, the depth must increase. So upthrust is directly proportional to the depth, which is why in order for the beam to remain in equilibrium, increasing the distance of the person from A will increase clockwise moment, and to increase the anti-clockwise moment, this depth must also increase in a linear pattern. So you'll sketch a straight line graph with a positive gradient. A truck R of mass 9400 kilograms moves with constant acceleration in a straight line down a slope, as illustrated in this figure, At point A, it has a speed of 13 meters per second. And at point B, it has a speed of 22 meters per second. They are at 180 meters away from each other. You're supposed to calculate the acceleration. Since this truck moves in a constant acceleration, with constant acceleration in a straight line, here you can use this formula to find the acceleration. So that would be determine the gain in kinetic energy of truck between A and B. You will notice this pattern where you're supposed to find the change in kinetic energy, and that is a question worth 3 marks. You'll start by stating the formula and then find the change using the change in velocity. The mass over here is 9400. The final velocity squared minus the initial velocity squared will give you the change, and that is equal to 1.5 times 10 raised to 6 joules. Correct to 2 significant figures. A short time after passing point B, truck R moves in a straight line on the horizontal ground. The driver of the truck applies the brakes. Figure 3.2 shows the variation of momentum with time for this truck. So initially you start with some momentum, and after some time it comes to rest, because momentum being 0 means the velocity must have dropped to 0. Define force. Now that we are dealing with momentum, let's think about force and how it relates to momentum. So that's rate of change of momentum, where the formula goes as such. Show that the average resultant force acting on the truck R between time 0 and 15 seconds is this value over here. As we just said, resultant force is equal to the rate of change of momentum. That means change in momentum divided by the time taken for this change. The time would be from 0 to 15 seconds, so that's 15. And now you need to see the final and initial values between 15 and 0 seconds. Initially you start out with 21 times 10 raised to 4 kilogram per meter squared, and after a period of 15 seconds, that is equal to 2.5 times 10 raised to 4. So this would be equal to the figure provided in the question. An identical truck S has the same initial momentum as truck R. So initial momentum for truck S is equal to 21 times 10 raised to 4. Truck S experiences a constant force equal to the force in B part 2. And this force is equal to negative 1.2 times 10 raised to 4 newtons. State and explain whether truck S will take more or less or the same amount of time to come to rest as truck R. When the truck comes to rest, its final momentum is equal to 0. Because both the trucks have the same initial and the final momentum, that means they have the same change in momentum. So change in momentum for truck S is equal to change in momentum of truck R. The time taken for truck R to come to rest can be found using this graph. It comes to rest when the momentum drops to 0, which is somewhere around here. Okay, so this is 5 seconds. That means the smallest unit over here is 5 divided by 10, which is 0.5 seconds. That means you have 20.5, 21, 22, and that's 23 seconds. The time taken for truck R to come to rest is 23 seconds. But we don't know that for S. We can find that using the formula where the resultant force is equal to change in momentum divided by the time taken. You rearrange that and divide the change in momentum by the resultant force. The change in momentum, as we said, both of them have the same value, which is 21 times 10 raised to 4, and the resultant force, as mentioned in the question, is equal to negative 1.2 times 10 raised to 4, and this is equal to 17.5 seconds. This is clearly less than the time taken for truck R to come to rest, which was 23 seconds. So for 3 marks, you're supposed to state that both trucks have the same change in momentum, where truck R comes to rest in 23 seconds and truck S comes to rest in 17.5 seconds, which is less time than truck R. For a device containing a microwave emitter and a receiver is placed in front of a large metal sheet in vacuum as shown in figure 4.1, the line XY is perpendicular to the metal sheet and the device emits microwaves of frequency 6.3 gigahertz, so that's 6.3 times 10 raised to 9 hertz. When the device is at position P, a stationary wave is formed between the device and the sheet. Explain how the stationary wave, including nodes and antinodes, is formed. A stationary wave or a standing wave is formed by the superposition of two waves that have the same frequency and the same amplitude traveling in opposite direction. So imagine if you were to have microwaves traveling from the source, they hit the screen and then they are reflected, right? Now at one point their amplitudes would overlap to result in an increased amplitude, and this results in constructive interference when the amplitudes add up, and this would form an antinode in the resulting standing or stationary wave. When the crest and the trough of these two incident, let's say this was the incident wave, the wave that heads towards the screen, and then you have the reflected wave, right? So when their trough and peak overlap, this cancels out the amplitude, leading to this destructive interference that produces a node in the standing wave, and the standing wave would look something like this, where these are the area of maximum amplitude, these are the antinodes, and these points are all the nodes, the areas of minimum or zero amplitude. So as for how they form is, the microwaves travel from the transmitter to the sheet where they'll get reflected. The incident wave and the reflected waves will superpose or overlap. The maximum amplitude will occur at antinode and minimum amplitude will occur at anode. Calculate the wavelength of the microwaves. Recall the formula. Wave speed is equal to frequency times the wavelength. We were informed that the frequency over here is 6.3 times 10 raised to 9 hertz. The wave speed of microwaves, which are part of the electromagnetic spectrum, would be 3 times 10 raised to 8. Therefore, the wavelength would be equal to this ratio over here, and that is 0.048 meters. Correct to two significant figures once again. At point P, the receiver detects a maximum amplitude. So once again, maximum amplitude, that means an antinode at point P. The device is moved slowly from P along the line XY, and the receiver detects a series of minimum and maximum amplitudes. The first time a minimum amplitude, meaning a node, is detected by the receiver is when the device is at point Q. Okay, so from point P to point Q, you observe the first antinode and then the first node. Remember what I said about how a node and an antinode looks like on a stationary wave. Antinode is this point over here. So let's assume this is point P. The next node, that would be this one over here, is point Q. Determine the distance between P and Q. What you need to understand here is the distance from one node to the next node is half of a wavelength. So that's this one over here. This is half of a wavelength. That means since P is midway between that means the distance from P to Q, or the distance from an antinode to the next node, is equal to quarter of a wavelength. So PQ is quarter of the wavelength, which we just found was 0.048 meters. That means this distance is equal to 0.012 meters. The intensity of microwaves emitted by this device is increased. The frequency of microwaves is unchanged. Okay. Intensity increasing. What does that mean for this wave? Intensity is proportional to the amplitude squared. That means the waves are just now going to have larger amplitudes of their crest and trough, meaning that the resulting antinode would have a greater amplitude. That's all it means. The device, okay, and the frequency of the microwaves is unchanged. Frequency is inversely proportional to the wavelength. Since wave speed is constant, that means frequency remaining constant would also mean that the wavelength over here remains constant. The device is moved slowly along the line XY from point Q until the next maximum amplitude, that meaning until the next antinode is detected. So let's come back to this visual representation over here. Now the device is moved from Q up until the next antinode, the next maximum amplitude. So that would be this distance over here. State and explain whether distance QR, okay, this is point R, is greater than, less than, or the same as point PQ. Well, as we saw earlier, PQ was quarter of the wavelength. It depends on the wavelength, and since frequency and wavelength do not change, that means QR, which as you can see, QR is equal to PR, because both of them are distances from the node to the next antinode. Because the wavelength does not change, that means this distance also remains the same. The distance PQ is equal to QR. A stationary loudspeaker emits sound of frequency of constant frequency, where a microphone is placed near to the loudspeaker and connected to a cathode or oscilloscope, and the screen from this CRO is shown in figure 5.1. The time base of the CRO is set to 5 times 10 raised to negative 4 seconds per centimeter. So they're telling you this 1 centimeter represents or is equal to 5 times 10 raised to negative 4 seconds. Because each centimeter, as you can see, has 1, 2, 3, 4, 5 divisions. You can find what each division here stands for by dividing this value by 5. That means each division equates to 1 times 10 raised to negative 4 seconds, or 0.1 milliseconds. The speed of sound emitted by the loudspeaker is 330 meters per second. Determine the wavelength of the sound. Okay, I should have prefaced this by saying the x-axis on the CRO represents time, right? Since wave speed is equal to frequency times wavelength, where frequency is the inverse of the time period, that means wave speed is equal to the wavelength divided by the time period. So you can substitute this formula to find the wavelength, where you'll multiply the wave speed by the time period. Wave speed is already given. You need to find out the time period, or the time it takes for one complete oscillation, and you can use the CRO to do that. You can pick any 2 points, the initial and the final one. Let's say that I pick this point over here and then this one over here. Let's count the number of divisions between them. First off, you have 1, 2, 3, 4 and 5 divisions, and aside from that you also have this unit over here, and then that's 1, 2, 3 and almost 4. This one over here is a bit more than 1, so that accounts for the small subtraction that you can almost see from the last unit. So that's 5 centimeters plus 4 divisions. That's how long the time period is. Since we know that each centimeter is equal to 5 divisions, that means the total number of divisions in the time period is 29 divisions. So the time period is 29 divisions. As each division stands for 1 times 10 raised to negative 4 seconds, that means 29 divisions can be converted into this time period as well. So that gives you 2.9 times 10 raised to negative 3 seconds for the time. So now you can find out the velocity by this product over here. And that is equal to 0.96 meters. Correct to two significant figures. The loudspeaker now moves in a straight line while emitting the same sound of constant frequency. The period of the trace on CRO increases continuously. Describe the motion of the loudspeaker. If the time period increases, and we just said that time period is inversely proportional to the frequency, that means increase in time means that frequency must be decreasing, or the wavelength, which is inversely proportional to the frequency, must be increasing. So you need to know these two relations over here to be able to answer this question. We know from Doppler's effect that observed frequency is less than the source frequency when the source moves away from observer, which is exactly what's happening over here. The frequency is decreasing. In other words, the observed frequency is less than source frequency. That means in this case, the loudspeaker must be moving away from the microphone to result in a lower frequency. As for the second part of this answer, which is why you have 2 marks, the time period increases continuously. What does that mean? Let's look at the formula of Doppler's effect, where observed frequency is a source frequency times speed of sound divided by speed of sound plus or minus the speed of source. Because the source is moving away from the observer, that means you would add that speed in the denominator. Now, the source frequency and these two values are constant. That means if the observed frequency is varying here, which it's going to decrease, it's mainly happening because of the speed of source changing. If the observed frequency is decreasing and speed of source is inversely proportional to that, that means speed of source must be increasing. So knowing this relationship, we can deduce that time period on the CRO increasing continuously means that you don't just observe a singular change in the value of observed frequency. Instead, the time period increasing continuously means that the observed frequency also decreases continuously. And as we just saw from the formula, this is inversely proportional to the speed of source. Therefore, the speed of source or the loudspeaker must be increasing continuously. That is, the loudspeaker must be accelerating as it moves away from the microphone. A cylindrical copper wire of length 0.24 meters shown in figure 6.1, where you are given a certain number of values. Calculate the potential difference between two ends of the wire. According to Ohm's law, potential difference is the current through the wire times the resistance. So that would be 3.3 milliohms, which is equal to 2.8 times 10 raised to negative 3 volts. Show that the cross-sectional area of the wire is 1.3 times 10 raised to negative 6 meters squared. Knowing that resistance is resistivity multiplied by length divided by cross-sectional area, you can rearrange the formula to find resistance over here. Which is equal to the value provided in the question. Show that the number density of the charge carriers in the wire is 8.3 times 10 raised to 28 per meter cube. Okay, we know of the formula where current is equal to cross-sectional area of the conductor times the charge on a charge carrier multiplied by the number density and the drift speed. Since we don't have the drift speed, we can't exactly use this formula. So you need to use your understanding of what the number density of charge carrier actually means. It is equal to the number of charge carriers per unit volume of a conductor. We were informed about this number of charge carriers in the question earlier, and that is equal to 2.6 times 10 raised to 22. As for the volume of this wire, which is in the shape of a cylinder, that would be cross-sectional area times its length. Cross-sectional area was also calculated previously, which is equal to 1.3 times 10 raised to negative 6 multiplied by the length, and that is equal to the value provided in the question. Once again, calculate the average drift speed of the charge carriers. Now you can use this formula, rearrange it, make the drift speed the subject of formula, and divide it by this product over here. So that would be equal to the current divided by this is the value of a charge on a charge carrier. It would make calculations much easier if you could just remember that. However, you can also find it at the beginning of this question paper. And this leads to final answer of 4.9 times 10 raised to negative 5 meters per second. C. A different copper wire Q has the same volume as wire P, but non-uniform radius as shown in figure 6.2. So this radius is going to vary from, specifically decrease from R1 to R2. And you're supposed to state and explain how the resistance of wire Q compares with that of wire P. We are informed that volume of wire Q is equal to the volume of wire P. Since volume is the product of cross-sectional area and length, that means their products must be the same. But we can see that the cross-sectional area of wire Q is decreasing. That means its length must be larger than that of length P to maintain this ratio. So now we know for sure that length of wire Q is greater than length of wire P. And obviously cross-sectional area of wire Q is decreasing. That means as you go further along the length of this wire, the cross-sectional area decreasing would increase its resistance along this length. But here you are not asked to describe this change, only to compare it with wire P. Since resistance is equal to resistivity times length divided by cross-sectional area, where resistance is directly proportional to length and inversely proportional to cross-sectional area, you'll use this relationship and the fact that length of Q is greater than length of P. That means increasing length for wire Q will increase the resistance of wire Q. Also, considering that the total or the average cross-sectional area of Q is less than average the cross-sectional area of wire P, and knowing that it's inversely proportional to the resistance, decreasing the cross-sectional area would also increase the resistance of wire Q. So both of these factors lead to an increased resistance for wire Q. Part 2, on figure 6.3, sketch a graph of the variation of average drift speed of charge carriers with distance from end X of wire Q. Let's look at drift speed once again, which is equal to the current divided by cross-sectional area times number density times the charge on a charge carrier. The current on this wire, along the length of this wire, will remain the same because here you need to recall Kirchhoff's first law, which states that the sum of currents entering a junction must be equal to the sum of currents leaving this junction. So this remains constant, and so does the product of number density and charge on a charge carrier. This is a constant velocity where the number density depends on the material, which obviously remains the same along the entire length. Therefore, the average drift speed is only dependent on the cross-sectional area, which is pi r squared. Along the length of wire Q, as the radius decreases, its cross-sectional area is going to decrease, and this has an inverse relation with the drift speed. So we are going to see as the distance from X increases, here's X, let's say, the cross-sectional area will decrease and the drift speed is going to increase. But is that increase going to be linear or not? Here's how you can find that. In this question, we are going to assume that the radius changes linearly with distance. So if distance from X is increasing by a factor of 2, that means radius is going to be also increased by a factor of 2. Okay, in this question, we are going to assume that the radius changes linearly with distance. So if distance from X is multiplied by 2, that means the radius would drop by a factor of 2, because we can clearly tell the radius is decreasing. And we also know that, so from this we can derive that distance from X is inversely proportional to the radius. Knowing this relationship and also that drift speed is inversely proportional to the square of radius, we can substitute this distance into the relationship between drift speed and the radius to sketch this graph. That means drift speed is inverse of this value over here squared. That means, what that actually means is drift speed is directly proportional to distance from X squared. Therefore, this curve would be, this increase in drift speed would be a curved graph. But before that, let me point out the fact that at a distance of 0 from X, that means over here, the drift speed is a non-zero value. So you must start above the origin and then increase the gradient of the graph from that point. Question 7. An isolated stationary nucleus Q decays into nucleus R and an alpha particle. The alpha particle has a speed as given in the question. You're supposed to complete the equation for this decay. So alpha particle reduces the mass number by 4. That means the initial one must have been 226, and it drops the proton number by 2. So the final one would be 86. By considering the momentum, calculate the speed of nucleus R after the decay. According to the law of conservation of momentum, total momentum before explosion must be equal to the total momentum after. As we can see, initially the nucleus Q is stationary, therefore initial momentum is 0, since momentum is equal to mass times the velocity. So this must be equal to the sum of momentum of particle r and alpha. For the sum of their momentum to sum up to 0, they must have opposite velocities that will be represented by opposite signs. Here I'll consider r with positive velocity. So mass of r is 222 units multiplied by its velocity, which is unknown. And then to that you will add the product of mass and velocity of particle alpha. So that's 4 units multiplied by negative 1.5 times 10 raised to 7. In other words, velocity of r is equal to, you would shift this product to the left hand side, so it would change signs from negative to positive, and this will give you the speed that you need to find out, which is 2.7 times 10 raised to negative 5 meters per second. State 3 quantities that are conserved during the decay. As we just saw, momentum is conserved, and from the equation where we balance the mass and the proton number, the nucleon number, which is essentially the sum of proton number and the number of neutrons, also remains the same. So the number of protons and the number of neutrons. We also see that the total charge in the equation remains the same. So that's one factor that you could also mention over here. And this is it. We are done with this paper. Thank you for watching.